This is third video of our chapter organic chemistry. In my previous video, I have explained you about organic compounds and about saturated hydrocarbon. Those are alkanes. But in this video, we will be talking about alkenes. Alkenes are unsaturated hydrocarbons. Unsaturated mean in which there is carbon-carbon double bond. As you can see from these structure, that carbon-carbon double bond. One is two carbon compound, other is three carbon, but one double bond. Next, you can see there are four carbons and there is at least one double bond. So, alkenes are the compounds which are made by double bonds, carbon-carbon double bond, and these are called unsaturated hydrocarbons. From where we get these alkenes? Petroleum. Actually, from petroleum, we obtain saturated hydrocarbons, and cracking of saturated hydrocarbons give us alkene, like ethane. Ethane, when cracked, gives us ethene and hydrogen gas. So we cracked a saturated hydrocarbons and we got one unsaturated hydrocarbon. Look at this homologous series of alkenes. One is ethene, then two carbons propene, and then butene, pentene, and hexene. One is C2H4, C3H6, and C4H8. You can see a sequence in this homologous series. What is the general formula for this? The general formula for this series will be CnH2n. As you can remember, what was the general formula of alkanes? It was CnH2n plus 2. But in case of alkenes, general formula is CnH2n. Okay. The same homologous series, the characteristics of homologous series will apply on this. As you are going down, carbon number is increasing, melting point, boiling point, density, viscosity, everything increases. All members are following the same general formula, and their combustibility decreases downward. So all those properties which we have studied in our previous homologous series, they will apply on this. What are chemical properties of alkenes? Chemical properties are alkene. The one is same as we studied in alkanes, that they are combustible. Alkenes undergo combustion, and complete combustion gives carbon dioxide and water. But incomplete combustion will give you carbon monoxide and water. Due to double bond, these are more reactive than the saturated hydrocarbons. Their double bond breaks and they add some incoming reactant. Means alkenes give addition reactions. As you can remember, alkanes, saturated hydrocarbons, they give substitution reactions, but alkenes give addition reaction. Whatever is reacted with alkene, it will be added. For example, addition of hydrogen. When you add hydrogen in ethene, double bond will break and each carbon will attach one hydrogen with it. But in this case, you have to give nickel catalyst. This hydrogenation process is very significant in our lives because margarine is made by adding hydrogen in oils. Means oils are unsaturated and they undergo addition with hydrogen and they make a saturated fat, that is margarine. Okay, nickel is the catalyst. The most important thing you must remember, catalyst. Nickel catalyst is used for hydrogenation. Okay, catalytic addition of steam in ethene. This process is used for preparation of alcohols. When you add steam in ethene, again double bonds of ethene breaks and one hydrogen atom and one OH ion is attached, OH group is attached with each carbon. Okay, and you will get alcohol from ethene. Means ethene to ethanol. Okay, there are also certain conditions for this reaction, like you need 300 degrees Celsius temperature. You need about 60 atm pressure, 6000 kilopascal or 60 atm pressure, and this reaction needs phosphoric acid as a catalyst. Addition of bromine. Bromine can also be added in ethene. When you add bromine, each carbon will attach one bromine with it. Okay, and unsaturated compound will convert into a saturated compound, because each carbon has attached one bromine in it. So what name will be given? Carbon number 1 has one bromine, carbon number 2 has one bromine. So we will write 1,2-dibromoethane. Why ethane? Because now the bond between carbon carbon is single bond. This reaction is also used as a test for saturated and unsaturated hydrocarbons. Only unsaturated hydrocarbons, they add bromine in it, and they decolorize bromine water. Do you know what is color of bromine water? It is orange in color, reddish brown orange. So when you pass alkene through bromine water will decolorize, while it will not give any change with alkanes, because alkanes are less reactive and they do not react with bromine. So again, bromine water can be used to distinguish between alkane and alkene. If something decolorizes bromine, it is unsaturated, it has double bond. If one does not give any reaction with bromine, means it is a saturated hydrocarbon. Like other homologous series, alkenes also give isomers. Along with branch structures, if I change the position of double bond, it will also give an isomer. As you can see from the different structures of butene, at first structure, the double bond is at first carbon. So we can say it is but1ene, and if I shift double bond to next carbon atom, it will make but2ene. Okay, can you understand the naming? Naming is according to the position of double bond. If it is at carbon 1, it is but1ene. If I shift double bond to the second carbon, it will make but2ene. Okay, and third, I can also make a branch structure. If I pluck one carbon and join it in the branch, it will be the third isomer of butene. You can also make closed structure. If you attach four carbon in a ring like a rectangle and make a single bond in all carbon and then join hydrogen with them, you can see it will also C4H8, and it will be another isomer of alkene. Try this. Thank you.